Okay, so all of us are right. We have Gani, Jamal, AFHAM, and RISSHE. And today is the April, which is we will start discussing about the mechanic assignment. So I'm gonna start with who will order the thing we need.
I think I will order it tomorrow.
And can we use your money first?
Yes, of course.
Okay, and so when we are expecting to do the assignment?
As soon as the item arrive, we should do it immediately, and we should do it before 17.
Okay, so when we talk about assignment, we need a lot of space, right? Then I will discuss about the location. And where do we want to do this assignment? Any suggestion?
I suggest to do this assignment at the house because I also have big space.
So the time period we will do this assignment like 1 week or
I think 1 week before is enough
no?
because the due date is 22 April, so 1 week before that, I think we need to complete it.
Okay, so the thing we will order in Shopee, right?
Yes.
And the estimated time, right?
About 1 week.
About 1 week. So,
Yes, 1 week.
so I'm expecting we're gonna start at 10 April. It's the earliest thing lah.
Yes.
10 April. So I'm expecting so 1 week, right?
Yeah.
So by 17 to 20, we will fully complete this assignment.
Yes.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. I'm AFHAM bin Muhammad AMRAN B0920104142 from BMMH S11. So today I'm going to present about the fluid mechanics assignments presentation, pressure in pipes. So our group consists of 5 members. Me, AFHAM bin Muhammad AMRAN, Jamal bin Abdul Gani, Gani anak Liman, Iman Alif bin AYUB, and RISSHE anak lelaki JEYASEELAN. So for the introduction, fertigation is a method of farming vegetables that reduce the quantity of watering required. There are 2 sorts of pipe configurations that can be used for watering, that are straight line and closed loop. These 2 alternative arrangements will result in differences in flow rate and volume of water received by each plant. This scenario will eventually affect the quality of plant itself. So, according to Bernoulli's principle, a rise in a fluid speed is accompanied by a decrease in pressure or a decrease in the fluid potential energy. This project under the subject of fluid mechanics will allow students to explore the effect of these configurations towards watering quality.
Assalamualaikum warahmatullahi wabarakatuh. My name is Jamal bin Abdul Gani, metric number B0920100253. In this presentation, my part is methodology. Equipment that we use in this experiment are 3/5 mm diameter single connector, next 16 mm T connector, next 16 mm times 10 meter hose pipe, next 5/10 milliliter measurement cup or measurement tank, next hose clip, next stopwatch. Okay, first experiment. The hose pipe that is clipped on the tap water by hose clip assumed to be same height from the ground for the water flow out from the pipe. The time taken to fill 250 ml is recorded. Second experiment. First, to analyze pressure variation in hose pipe over a specific pipe length with two different configurations. Second, straight line water hose configuration. Third, the time taken for each hole to fill up to 250 ml recorded. Third experiment. First, closed loop water hose configuration. Second, T connector connected the two pipes from the closed loop to the water supply. Third, time taken for each hole to fill up to 250 ml recorded. That's all from me. Thank you.
Hello, my name is RISSHE. I'm going to explain about the data and result. So for the first experiment, the length of pipe is 4.92 meters, diameter of pipe is 0.022 meters, time taken to fill 250 ml is 3 seconds, height of water supply is 1 meter, maximum height of water jet is 0.37 meters. So to calculate the flow rate is Q equals to BOT, where Q is equals to B is 250 times 10 to the power of negative 6 divided by the time 3 seconds. Answer is 8.33 times 10 to the power of negative 5 meter cube per second. So the velocity is 4q times divided by pi d squared, where 4 times 8.33 times 10 to the power of negative 5 divided by pi times 0.022 squared. So the velocity answer is 0.219 meter per second. So the maximum pressure is Y rho G. The pressure is 0.37 times 1000 times 9.81, and the pressure's answer is 3.3629.7 Pascal.
Assalamualaikum, my name is IMRAN ALIF bin AYUB, and my part is to present about the second experiment based on data and result. Okay, there is 5 holes on the second experiment, and for the first hole, the time taken is 24 seconds, and the flow rate is 1.042 times 0 power of negative 5, and the velocity is 0.052. And for the hole 2, time taken is 27 seconds, and the flow rate is 9.260 times 10 power of negative 6, and the velocity is 0.05646. And for the hole 3, just same with the hole 2, because the time taken also the same, 27 seconds, and the flow rate also the same, and velocity also the same. And for the fourth hole, the time taken increase, which is 29 seconds, and the flow rate is 8.621 times 0 power of negative 6, and the velocity is 0.043. And for the last hole, which is the fifth one, and the time taken is 30 seconds, and the flow rate is 8.333 times 10 power of negative 6, and the velocity is 0.041. And before I forgot, the diameter of pipe is 0.16 m. And then for the third experiment, there is 12 hole, so I will cover some of it. Okay, from the hole 1, the time taken is 32 and the flow rate is 7.813 times 0 power of negative 6 and the velocity is 0.039. Okay, for the hole 2 and 3, it has the same time taken, flow rate and velocity, which is 34 seconds. The flow rate is 7.353 times 0 power of negative 6 and the velocity is 0.037. And for the 4, 5, 6, it keep increase, and the 6th one is time taken 40 seconds and the flow rate is 6.250 times 0 times 10 power of negative 6 and the velocity is 0.031. And according to hole 7, the time taken is 39 seconds, the flow rate is 6.410 times 0 times 10 power of negative 6 and the velocity is 0.032. And for the hole 8 and 9, it also has the same time taken, flow rate and velocity, which is 37 seconds. So here flow rate is 6.757 times 10 power of negative 6 and the velocity is 0.034. And for the hole 10, the time taken is 35 seconds, flow rate is 7.143 times 10 power of negative 6 and the velocity is 0.036. For the hole 11 and 12, it has the same time taken, which is 12 is the last hole and the time taken is 33 seconds, flow rate is 7.576 times 10 power of negative 6 and the velocity is 0.038. The diameter of the pipe also the same for the third experiment, same as second experiment, which is 0.016 mm.
Hello, my name is Gani and Liman, metric number B092010-261, and I will present the discussion and conclusion. First, for discussion, the data obtained through simulation experiment is different. This is because of the water source is not a constant and different material is used. Next, in the straight line water hose configuration, the pressure is higher than the closed loop water hose configuration. And third one, the different water flow rate will have different pressure. Okay, next, for conclusion, we successfully show the experimental and simulation flow software utilizing the hose pipe. We also learn how the water travels in pipes and how pressure is distributed throughout the pipe via flow rate. Lastly, we also learn how to use animation in the creation of fluid flow to expand our knowledge of the subject. That's all. Thank you.